Hi, AP Calculus students. Welcome to 7.1C video part B. So you had a part A. This was not intentional to have a part A or B, but it's Sunday night, it's 6 o'clock. I want to get these done. And for the first time, remember how I said I don't like hitting the pause button? I did, because I had put something wrong here in the calculator. And so I hit pause to fix it. And of course, I lost the video, right, too. It went off to be processed and before I could save it and add on to it. So here I am. Next year, I'll put it all together. But if you could start here with me, notice I erased, part of the graph. But if we could start with in the last video where we were trying to find the area between the cube root of x minus 1 and x minus 1. And we needed the intersection points, and we did all that. And we found that it was at 0, 1, and 2. Okay, so 0, 1, and 2. Yep, I got it. Okay, so so what I did was then, here's what we had. I did the line first, right? Lines are easy. When you put in a 0, you get a -1. When you put in a 1, you get a 0. And when you put in a 2, you get a 1. And then what I was talking about was that, well, the cube root of x minus 1, you get the same thing, right? When you put in a 0, you get a -1 out. When you put in a 1, you get a 0 out. And when you put in a 2, you get a 1 out, right? And, but they're obviously not the same graph, okay? So why I stopped is I know what the graph looks like. It goes like that. But when I put it in my calculator, I hit a wrong button and got a wrong value. So anyway, let's go back. What I need to know then really is at 1/2 right here is the cube root graph above or below the line? Like I kind of need to know what's going on here at 1/2 and 3/2. And then that's where I made my mistake and my video got sent off to be processed. So when you put in a 1/2 into the cube root function, I did it correctly this time. That point about, let's call that about 0.8, a -0.8 is what we get. Okay, and obviously when you put a 1/2 into the line, you get a 1/2 out, a -0.5. So notice this graph then is lower than the line. So in other words, here's my line, right? And the graph is underneath, right? Let's see what's happening at 3/2 at 1.5. Let's see if I put this in right? So 1.5, obviously into the cube root, let's get that. 1.5, when I put it into the line, obviously I get a 0.5 out, so I'm good there. So let me go ahead and do very slowly the cube root. I'm okay. Nope, see, I hit wrong. See, Sunday night, trying to get it done. Cube root, 1.5 minus 1, so 0.5. Okay, there we go. 0.8. Okay, so some good symmetry going on here. So at 3/2 then, the cube root function is at 0.8. It's above the line, okay? And actually, I believe due to symmetry, these two areas are equal to each other. You probably could just do like 2 times one of these areas and get the full area. But what do we do here? Notice that from 0 to 1, right, that the upper function is the line and the lower function is the cube root function. If you don't mind, I just wrote the cube root as to the 1/3, right? Because if you're going to integrate it, you're going to have to add 1 to the exponent and add the new exponent, right? Then from 1 to 2, the cube root is the upper function and the line is the lower function. Okay, so what you would do here is integrate. And in fact, I was going to say, be really careful when you do it, but I made a mistake, right? So let's go one step further. Let's integrate, and then you can do your f of b's minus your f of a's. Okay, so let's take a look here. when I integrate, I'll write this out. Do I need to? Yeah. Here, let's just. I'm just going to clean it up a little bit. X minus 1, don't need the parentheses there. Minus x minus 1 to the 1/3 plus. Just going to clean up a little here from 1 to 2, right? X minus 1 to the 1/3 minus x minus 1. So this is a crazy little thing you got going on here. Again, I think due to symmetry, we could just do half of it and multiply it by 2, right? Double the area, because right, they're both going to be positive when you do upper minus lower, or you could double this area, right? But so let's go ahead and integrate. This would be x squared over 2 minus x. Now the integration of x to the 1/3 is I add 1 to the exponent and divide by the new exponent. The derivative of the inside function is still 1, so I don't need to use a u substitution here. So let's take a look. I have x minus 1, my new exponent is 4/3. And rather than divide by 4/3, I'll multiply by 3/4. So we will evaluate this from 0 to 1 plus, right? So again, I already integrated this, so I know what that looks like. 3/4 x minus 1 to the 4/3 minus x squared over 2 minus x, and I'll evaluate that from 1 to 2. So that's a lot going on. I did an extra step because I messed it up. So I thought, well, I'll do a little bit more with them so they don't have so much to do. So f of b minus f of a here carefully, f of b minus f of a there carefully. Thanks for watching part B of my video.